Hi everybody, this is Tor Storley, and I am back with another video. In this video, we're going to take a look at how you can use a package in R called OllamaR. It is an interface to your local Ollama models. So what I want to take a look at today is how we can use it, and I will go through some different demonstrations. And towards the end, I want to show you how I translated my code into a Quarto document. So it's much nicer to see the code and the tutorial that I'm given in this video. So without further ado, let's get started. There's Ollama and Ollama executable. So now it's up and running. Okay, so that takes care of that one. If you don't have Ollama, you need to go out and get the Ollama installer. Just do a Google search for it. And then once you install that, you should have Ollama sitting as an app. And you can just start it up to start working on this R package that we're going to be looking at. Okay, so let's open up RStudio. And it looks like this. I have a little dark theme here, but I hope that's okay. So as you can see, I created this R file and I set up some topics I want to go through using this Ollama. Let me max it up a little bit like that. You can probably read it okay now. In order for you to get started, you need this package. So go to packages and install this OllamaR package. So you just go in here. You can go against CRAN and go OllamaR like this, and then install it. Okay. So that's the first thing you need to do. Once you get that up and running, you can see here, this is the one that I have installed here. Okay, so the next thing we want to do then is we want to load this package. So I'm just going to run it like this. Control Enter on my machine, on Windows machine. So now that package is loaded. What I want to do now is I want to see if I can test my connection. So in order to do that in this Ollama package, you use this test_connection. Now, in case you wonder what you can do in this package, it might be a good idea to open up this package like this. And as you can see here, it has many different functions you can use to do this. And one of them is this test connection, as you can see. So if I click into that, you can see here, you can test the connection like this, or you can just test it without anything here. There's some additional parameters you can see they're showing you here. And most likely there's an example down here you can see. That's the first thing you need to do. Another thing I recommend you do, go into this user guide and the vignette here like this and open the HTML or the version you want to see. And in here now you can see there is outline of what you can do with this package. So you can see how you install the package if you want to do it by the console. You can also look at the usages. And also notice this, and this is something threw me initially because I tried it and I did it the wrong way. But you want to use the HTTR2 library. Actually, it uses that library. So, but you need to set a reference to it. So when you obtain your returns from running the Ollama models, you need to parse it out with that HTTR package. So as you can see here, I don't have to load it or anything. It comes in there when you install this, I assume. Make sure you check this. And also they tell you to download, install the Ollama app and so forth. So you can get some more information about how this works right here. Okay, let's continue. And what I want to do next then is I want to just figure out on my computer what kind of Ollama models do I have sitting on my computer. So the first thing I want to do then is I want to run this. So I created a variable here, which becomes a data frame, and I use this list models function. So what I can do then is I can go into my environment here, and there you can see is models. So if I want to see what models I got on my machine, let's make it big and let's just open it. So here you can see these are the models that I have on my machine. So I got this all mini LM latest. I got Code Llama 7 billion parameters. I got DeepSeek Coder 6.7 billion parameters. And you can also see the size here, how large these models are. And obviously, the more parameters they have, the larger they are. For example, you have DeepSeek R1 is 4.7 gigabytes. Llama 3.1 is 8 billion parameters, so that's 4.9 gigabytes. So in any event, you whatever Ollama models you have installed on your computers, you should be able to get that listing by loading the list models or use the list models function. So that's what I'm doing here. And again, when you run a simple script here, you can see here that I create a variable and I use this generate function, and it gives you a bunch of stuff you can fill in here. Okay, so what I'm going to do is to prove that this is actually running on my machine. And as you can see here, I'm in my network and internet panel. And notice Wi-Fi has been shut off. Now it's on, now it's off. So I have no Wi-Fi connection here, okay? I'm off the internet. I'm only running local here. If I test this connection here and run this, you can see I'm getting a status code back. And you can see it's running on this address on my local machine here. And you can see I got a 200 OK status. So it's running, okay? So it has connection to my models in Ollama. I'm running this in RStudio, as you can see. And I wrote the code here for different kind of tests I want to do on different models. So we got to have the basic setup and connection. And then we're going to have simple text generation. And then we're going to do some chat. And then we're going to have a code generation. And then we're going to do an explanation of code. And we're going to have some creative writing. And then we're going to do some structured data analysis. We're going to do some multi-model comparison. We're also going to try and visualize what these text embeddings are. So I'll show you the similarities and different sentences and so on and how closely they relate. Then we're going to do some batch processing. And then we're going to have advanced chat with system prompts. And finally, then you want to write some error handling for robust code. So that's the topics we're going to be looking at. Now, like I said before, this is an R script, right? It's this one up here. But that's not the final output I want. I want to pretty it up and make it look pretty. And therefore, I'm going to translate this into a Quarto document eventually. But I just want to get you started on this so you can see it. So as you can see, the first one here, you create a variable, you use the generate function, you pass in the model you want to use. So I'll just pick one of them and I stick it in here. Obviously, you want to pick one that performs good on the task you're trying to do. And here's a prompt. Explain quantum computing in simple terms to a 10-year-old, okay? So I'm going to use this Llama 3.2 latest model. And if you remember, the Llama latest is a 2 gigabyte model, okay? So it's not extremely large. And notice this is the kind of way I did it. I capture the response and it comes back as a JSON object. So I'm passing in this simple response with the model and the prompt. We passed into this function here. And then it get loaded in here to this variable. And then I want to print out so you can see what it looks like. And these things are just new line characters, okay? But I'm passing in the result of this here. And notice when you run this, you're going to see like it pauses and give you a red stop sign while it's running. So I'm going to run this. And you can see it over here. Here's the stop sign on the top here. And once that finishes, then I'm going to go and actually look at the output. So now it's finished like this. So if you look at it now, look at the layout here. And this, the reason I'm going through this is because this pattern repeats itself over and over. So as you can see here, there's a lot of parts here. All of these variables you can capture, okay? So you can print them out. So the one thing you can see here is that there's a model parameter. It will tell you which model you ran. It tells you when you ran it, like the created date. And then you have the response. So what we're interested in is that response, right? And that one is loaded in here, as you can see. So that's this portion of it. That's the response, which is equivalent to this. Okay, so now you can see this is the actual answer. So imagine you have a huge box of different colored balls like red, blue, and green. Each ball represents a possible answer to a math problem. So here you're explaining, or trying to, I don't know how good this explanation is, but you're trying to explain quantum computing to a 10-year-old, okay? All right, so you can see that's the response object that came back. As you can see here, I have different ones, and I have this kind of set up for all of them. And you can see I'm stepping through each one of these. And so this is my R code, RStudio's code. But I'm not going to do it here. The rest of the presentation, I'm going to go and do in Positron, not RStudio. By the way, I'm going to make my files available on the my GitHub repository for this tutorial. So check out for the code there. So let me close this now. And I'm not going to save the R data object. So instead, I'm going to open up Positron. Let me move it over because it always open in my other terminal. Here you can see I have a bunch of stuff up here. And there's also something called OllamaR cache. You see that? What it does, it creates a folder and it dumps in R data objects. And so as it goes through it, and you can see advanced chat, batch result, chat conversation. So these are some of the things that I've been running to create this Quarto document, but it also caches a bunch of the stuff here. So I don't know if it does that, so in case it looks for something similar, I can just grab it from the cache and it goes quicker, something like that. I went through this Quarto document here, and as you can see, you have some titles, and the document I'm going to use is not going to be this one because I'm not going to run it again, but there will be a couple of differences. The author name is not in the documents that I spooled out. But as you can see, it has the format's going to be HTML. Here's the theme I'm going to use for my Quarto document. And then you have some depth, like the table of content depths and so forth, code summary, whatever. And then a bunch of CSS, as you can see here, that's going to model the output so it looks better. Then you can have no warnings. I don't want to see any messages. Use the cache if you have something so you don't have to repeat it. And then I'm loading my libraries here, as you can see. I'm going to load the OllamaR Great Tables library, dplyr for data wrangling, and then also HTML tools because I want to use some of the HTML techniques. And then, of course, knitter will be part of this as well. We already looked at the first request with a simple one, but I also have some helper functions here. As you can see here, this is one we're going to be using for most of it, and this is another one. And to get the output to look good, I'm using this paste zero function. So this is a new line, and you see there's like three, what do you call these things? Colons, is that what it's called? Three of them that will create inside here. I'm going to load this, which is going to be the actual class. So there's a class called AI response up here somewhere. So if you look, here's the AI response in the CSS. So it's going to format it like this every time. But what Quarto does is it uses these three colons to create a div object. So all of this stuff is going to be inside a new div, okay? I'm going to pass in the title and the content here. And these are new line characters. This is a markdown for bold. And yeah, so you can see how it does this. And then this one is another function we're going to be using. These two are going to be used. And I have some text coming like this. And then I have some, we've just ran this basic setup and stuff. And you can use these little icons, make it look pretty. And also you use try catch if you want to, catch the errors and so forth. You can see here if you don't succeed with your connection, right, the status. If it's successful, you get that 200 and that stuff. Otherwise, you'll get the failed message here. And we did this, the model stuff, to list the models. Also, I'm creating some nice, great tables in R here by running, using the dplyr, as you can see, and the magrider piper here. So you're passing in the model, and then you do some additional stuff. You pass that into Great Table here. And in case you wonder about Great Tables, I made a previous video on Great Tables in Python. So this, now we're in R, and in Python, I think it was capital G, capital T, but in R, it's lowercase, as you can see. So you pass in, you add a header, you have column names, a table style, and so forth. And here it prints out the new div with the response and so forth. So this document continues like this, as you can see. And instead of going through all this code here, I'll point to the code when we get into something that I need to show it. But for now, I'm just going to show you and go through my final document for this. So let me bring that over. Let me minimize this now. So here is the Quarto document. And by the way, if you work in Positron and once you've written all your code and so forth, you can simply go up here to this preview button and click on it, and it will create the document for you, assuming there's no errors. If you do get errors, you will see this spinning and spinning, and it will tell you there's some errors. So you just go in there and cancel it, and then you fix it, and then you try again. So, and once you get this preview up, and there'll be a little table on the right-hand side, and then you can just click this guy to bring it in as an HTML. It will save it to your drive here as an HTML document. So you can see it there. And I'm going to make it just one step. Well, actually, not yet. If you look at it here, it's already at 150. If you look at my document, notice it creates a table of content because I had that in the code. If you remember, you can see code fold. So that means you have little arrows. You can click it to view the code. And you have table of content is true. And then you can have 3 levels if you want to. Now, so as you can see, here's my table of content over here. Each one of those thing. And notice this one here. This is the one code fold. You can see you can show the code. You can hide the code to minimize the size, right? So here you can show some other code. So for each one of these here, there's some code. And you can view it right here in this document. But notice how it laid it out nicely. You get an introduction. I'll tell you what we're going to do here. And here's the package we're going to use. It creates these code snippets by using this right here, as you can see. All right, so notice here, I'm getting some nice looking tables because I use great tables to do this. And here's the code that generated this. So you can see here, I'm testing the connection. I'm loading, listing the models. And then once you get that object, like models here, you check it to see if there's models first, and then you pass it in here, and you create an output variable like this. So pass the model, pipe it to the next, select the name size and modify it from that model, and then you do some additional formatting here. I don't think I have more than 10 models. So, and then you pass it into the great tables, and then you structure and set up the look and feel of that table. And then I just print it out, as you can see here. So once I do that, let me minimize this again. Here comes the table. And it looks pretty good. So here you can see all your models, the size and so forth. And also it printed out the connection, so it was successful. This is the one we just did. We did this in RStudio. You remember this? Here is the output that it generated. Remember in RStudio, it was pretty ugly to look at. And now it's nicely formatted here, as you can see. So the question was, explain quantum computing to a 10-year-old, right? And here you can see the output of that. You can also do interactive chat. So what I did here was I say, hey, use this model. Here's my message. And what I want to do is I want to be the user. And I'm asking, if I'm going to travel to Norway, what is 3 of the places I should be go and look at? And here you're getting the content and so forth. When you run that code, notice I'm using the 3.2 latest model. And here it tells you what the 3 places are. So let me say Trolltunga. Yeah, that's a nice one. I don't know about this one. It's charming to be if you're in Bergen, but it's not the one I would go to. And then Northern Lights, yeah. Those are nice, but, I'm not necessarily agreeing to these places, but this one is pretty cool. Next thing is code generation with OllamaR. So what does that mean? Well, here I'm creating a Python object and use the generate model, use the OllamaR 7b model, and I'm saying write the Python function that calculates the following financial metrics: net present value, internal rate of return, and payback period for a given cash flow series. And here you can see I'm spooling it out. So it follows that familiar pattern here. I grab this and I put it in here, and then, I print it out at the end. And here I do the same thing for our code using OllamaR again. and I say, write an R function that creates a beautiful ggplot2 visualization of the penguins data set. All right, and then it does that. So let's see what it did. Well, here is the Python code that it generated. I had this financial functions file, and I just created a Python notebook, as you can see here. But I had to change a couple of things in here, so it didn't work right out of the box, but it was close, okay? But I don't know if it will run if I try to run this now. Let me test and see. Well, it did something, so let me see what it did. So if I run this now, I pass it into this financial metrics function you just loaded up there. And okay, it came back with some results. So that code worked pretty much right out of the box. Here's the second function, and here's the third function. So yeah, they work. And the interest rate, I believe, was fixed, 5%. Yeah, you can see it up here. Anyways, so that code came out and it worked actually. So that's pretty cool. And let me go back in. Then I did you can see here is the test cases that it suggested. And then the data visualization function, I ran that, and that worked too, actually. So yeah, here's the function that it produced for me. Okay, so here is code explanation with DeepSeek Coder. So here's the code. Use this DeepSeek Coder 6.7 billion parameters. Explain this R code by step, and then I'm passing in like, hey, you have dplyr library, you do the piping and so forth, and then print out the results. So it's pretty straightforward. And I start here with the library, this loads, and you can read it yourself. I'll make this available to you. You can go through it in more detail. I just got to keep moving because we're running late already, as it looks like here. But anyway, it's pretty cool, using all these different models for different methods. You can do some creative writing with custom parameters. So here, what I did was I use different temperatures. You see this? There's a top P, there's a temperature of 0.8, for example. And what you can see here is that with low creativity, right? If it's 0.02, then it's not very creative. If it has a temperature of 0.8, it's very creative, right? All right, so anyways, if it's 0.8, it's creative. If it's 0.2 for temperature, it's not so creative. And I can't remember what this top P was. I used to know what it was. But anyways, so here it is. And then my prompt was, write a short story about the origin and development of the double entry system of accounting. So let's see what it did. All right, so let's look at the high creativity. You say, it was a chilly winter morning in 1494 when Luca Pacioli, a young monk from Italy, stepped into, and so on and so on and so on, right? Now, let's compare it with the low creativity. It was a chilly winter morning when Luca Pacioli, here he is a Franciscan friar and a mathematician. Here he's a young monk, right? So depending on how you set these parameters, it will give you different results. So that's something you need to kind of look at. So this was an interesting exercise to pass it in at the different temperature levels. Okay, now here is some structured data analysis. So what I'm happen to ask here is analyze the pros and cons of remote work versus office work. Present your answer in a structured format with clear headings, okay? So as you can see, it has clear headings, so that's nice. And it prints out this content, and it goes through, flexibility. Those are the pros of remote work, increased productivity, and so forth. So you can read up and see if you agree with these. But the nice thing here is that because you have this present your answers in a structured format with clear headings, it lays it out very nicely. And as you can see, in this particular case, you use this Llama 3.2 latest model. So you get some really nice results here, I think. Okay, let's look at the next case. Here is a multi-model comparison. So what does that mean? Well, what are the key differences between machine learning and artificial intelligence? Okay, I'm going to use that 3.2 model again. And here's the prompt question, which is this one here. And then you're going to print it out. And then I'm going to do the same thing, but I'm going to use a different model. DeepSeek Coder. like this, and then run that, and then create a comparison table, as you can see. And when you do that, you pass that into Great Tables, and you continue like this. So what did it do? Well, let's see. The Llama 3.2 response focus was on this general AI knowledge, and the length was 1,987 characters. And this DeepSeek coder produced 2,128 characters, and the response focus was on technical and coding perspective. So that shows you a little bit about how each model is viewing the content of what you actually prompted for. And here you can see the model responses if you want to read details of these two answers up here, the emphasis and so forth. All right, so here's the DeepSeek coder. Looks pretty cool with all these different layouts, doesn't it? Looks like I got something going on here. Okay, text embedding. This one is interesting. So if you look at it here, I create some texts. I have 4 sentences. I love R and data science. I went to the zoo and looked at the wild animals. I think that the tiger is the most awesome animal in the world. In Africa, you will find wild lions as well as elephants. Now, what do I do with this? Because I want to see how closely the embeddings are going to be when you actually run this stuff to figure out, the similarity between these sentences. So how do you do that? Well, create a variable and make it into a list object. And then for this sequence along text is going to be the length of the text. You create a sequence on it, on the length of it. So what you're going to be doing is, this is the model I'm going to use, which is a kind of strange embedding model, this one that I have in my list. And then you input the text, and then you load it into your list object up here. Okay, so that's the first one. Then you use a cosine function. And by the way, you can look this up. Just go into look at embeddings in that OllamaR model, and you'll see some more about these embeddings. But it uses the cosine function here, and the formula is not important, but basically it calculates how closely together these sentences are going to be, meaning the tokens in this sentence. They all be brought down as numbers anyway. So it will compute the nearest one and so forth. And then you have this matrix here you're creating, and you're building this matrix using this cosine similarity function you see here. And then finally, you create a data frame and you push in the stuff and you create a table out of it. So what does that look like? Well, so let me show you the code. So here you can see the output, and here you can see the reference text. So text 1 is I love R and data science. Text 2, I went to the zoo and just looked at the animals. Text 3 is the tiger. And text 4 is in Africa, you find lions. So what happened? Well, let's look at the matrix up here. Notice the top one is this 69% text 4 match against text 2. So what we're saying is that this one, I went to the zoo and looked at the wild animals. In Africa, you find wild lions as well as elephants. So it says that 2 and 4 was very close together, as you can see. 69 is probability of 69. And if you look at some of the others here, obviously text 3 is 100% similar to text 3, and because that's just the way it is, right? And so you're always going to have this diagonal 1, 1, 1, 1 here. So this one here is the same thing. It's text 4 against text 2. This is text 4 against text 2. So you see it twice here, right? You could have just only had the bottom portion here or something. But that's kind of cool because it gives you the similarity between these sentences. All right. Next one is the batch processing. So if you look at it here, here's the topics: climate change, artificial intelligence, and space exploration. So you're going to run this against your Ollama models using these different prompts. So you're setting up a topic of type character, response character, word count, numeric, and so forth. So this is the batch results. And then you have a loop over the length of the topic. So 1, 2, 3, and so depending how long the topic is. And then it does a printout here, as you can see. And there's a result you generate, and here is the model. And then you are basically capturing the response, and then you bind it and row bind it here, and then you basically spool it out. So here you can see processing topic 1 of 3. So it loops through each one of these topics and run it through the model. So this for this one, and this one. And once it's done, topic 2 of 3 and topic 3 out of 3. Here you can see the batch processing summary. So it tells you how many words is in each output here and so forth. So here you can read it for yourself. Here's the climate change, here's the artificial intelligence, and here's the space exploration. Very cool. Okay, we're almost there. Advanced chat with system prompt. Okay, so here's the code, and it's getting longer and longer now. But basically what you're doing is you're creating system prompt here, and you have a user as well, the roles. Okay, we use the OllamaR 3.2 latest model. So let's say you're a helpful data science tutor. Always provide practical example and suggest R code when relevant. So you actually want to suggest R code here in the output, okay, when it's relevant. And then the user asks, how do I handle missing values in my data set? And then you have the usual suspects. You capture the response, and then you build a chat metadata where you create a data frame. These are the attributes, the model, the created, the roles, and the length. And then you set up it down here, and then you pass it into the table as usual, and then you print it out. So when it's all said and done, you can see here is the model, and here is the created date, and so forth. So basically, I'm capturing all that in that table you can see up here, right? You can see the content. It comes from here, this one, and then capture the model, the created that, and I showed you where that was when we did it in RStudio. So here you can see, here's the data response, and you can see here that it explains to you different things here and shows R code if it's possible. I don't see it here though. Here you can see some R code it produced for you, because if it's relevant, you want to show the R code. That's what the prompt was saying up here, right? At the very top, right here. Okay, this first sentence here, provide a practical example where relevant. And that's what it does. And here you can see for regression, here you can see some extra code. Here's some deletion, pairwise deletion, and multiple, yeah. So it goes on and on here, and you can read it on your own. Okay, finally then, error handling. Okay, so it basically shows you how to use this in a try-catch kind of method here. I don't want to go through all this code, but basically it attempts to run the stuff, and if it fails, it performs a certain way, and also use a sleeper function here. And then you basically run it, and it will tell you how many attempts it took for you to finish. If there's a problem, it will stop it, right? One thing to point out is that you set the number of attempts for 3, okay? So we'll try to run it 3 times and see if it succeeds. And here's the output. 1 attempt, and it was successful. The question was, what is the capital of Norway? And here's the answer. So you can always navigate back and forth here by clicking the sidebar here and going up and down. I hope you liked this video, and if you do, please give me a like. That would be very helpful. And consider subscribing to my channel. That would also be very helpful. And I will see you in the next video.